This is an image of a portion of the female reproductive tract, specifically taking a look at the ovary. So just like in the male reproductive tract, how the seminiferous tubules were the site of sperm production of the gametes, the ovaries are the site of egg production in the female. So the ovaries are responsible for not only producing the egg, but they're also responsible for producing hormones. So we know that, and you've probably already read, that the brain, particularly the anterior pituitary gland, is responsible for producing the hormones FSH and LH. That was follicle stimulating hormone and luteinizing hormone. The ovaries actually produce the hormones estrogen and progesterone. So the interesting part of that to me is that as these individual eggs are developing, it's actually the follicle or the cells surrounding the egg that are responsible for producing those hormones. So what happens is that each month after puberty begins in a female, a few of these developing eggs start to grow. And as they grow in size, they begin to secrete estrogen and progesterone. They continue to grow, they begin to fill with fluid, as you can see here in this example, and usually about midway through the cycle, this follicle begins to push so tightly against the outside edge of the ovary that it actually ruptures, and the egg, with some of those follicular cells, gets released, leaving behind the remaining section of the follicle. Now this remaining portion of the follicle ends up being converted into another form called the corpus luteum. And this corpus luteum continues the hormone production that the cells surrounding the egg were producing at the beginning of the cycle. So we really have two forms. We have the follicular phase of the ovaries here at the beginning of the particular menstrual cycle, and we have what we call the luteal phase during the second half of the menstrual cycle, and both sections of tissue are responsible for producing these hormones. This is actually an image of what it looks like during the actual point of ovulation. One of the interesting things about this in particular to me is that the ovary, which is seen here, does not actually come into physical contact with the fallopian tubes. This is the very edge of the fallopian tubes called the fimbriae. These are the finger-like edges that move around and they sweep, and they actually create a current in the peritoneal fluid that pulls the egg into the fallopian tube. So I just wanted to show you guys this because it's so neat to see that. The egg is within here. All of these little dots, these are all parts of those cells, the remains of the follicle, that actually continue to secrete hormones until the corpus luteum takes over, and then until the placenta gets formed later on after that. But this just shows you the physical gap between the ovary wall during ovulation and the fimbriae of the fallopian tube. As the egg ovulates from the ovary and then moves into or gets swept into the fallopian tube, it begins its process, its transport from the end of the fallopian tube down into the uterus. Now, one thing, we mentioned the fimbriae here at the edges that are creating the current in that fluid. We also have cilia that line the inside of the fallopian tube that help to move or kind of waft that egg all the way through the length of the fallopian tube. Now, if a fertilization is actually going to occur, this actually happens in this upper region of the fallopian tube. So just to make sure that you know that. So fertilization happens about right here, and then the fertilized egg continues its movement down into the uterus and eventually will be implanted into the endometrium. So let's take a quick look at the lining of the uterus itself. There are two major layers that we need to talk about. One is the endometrium. This is the inner lining of the uterus. This is the lining that gets built up really thick during the middle of the cycle, and it's the lining that gets shed during the menstrual cycle if pregnancy does not occur. If pregnancy does occur, then the egg gets implanted here in the endometrium. All of the rich blood vessels that are built up in the endometrium are what nourish the egg, until the placenta is formed, where there's a really great connection between mom and baby for transfer of nutrients. And that doesn't happen until about 3 months into the pregnancy. So this endometrium and that thick lining is extremely important in keeping the pregnancy viable for those first few months. This other layer that you see here in the middle, this thick layer, is called the myometrium. You should recognize that myo refers to muscle. This is the smooth muscle lining in the uterus. This is where all the labor contractions initiate. This is, excuse me, the layer of muscle that has the receptors that we talked about earlier on in the semester for oxytocin that stimulate the contraction of the smooth muscle in the uterus that involve labor contractions. And here at the bottom of the uterus, a portion of it is called the cervix, and this is simply the opening to the uterus. The opening here is what you hear referred to when you're talking about dilation during labor, that this opening to the cervix or entrance into the uterus has to reach a point of about 10 centimeters of dilation in order for the baby to be born. The last section that I'd like to talk about is the actual hormonal cycle that's going on within the woman's body, and there are quite a few different pieces we need to take a look at. Remember, FSH and LH are being secreted by the pituitary gland, so these are coming from the brain. FSH stands for follicle stimulating hormone. So when FSH is secreted at the beginning of the cycle, the follicle, or the cells around the egg, begin to grow and grow and grow. So we're maturing the follicle. When you get a big spike in LH, this is called luteinizing hormone. That is what's going to actually trigger the ovulation event, where the egg ruptures, or the follicle ruptures from the surface of the ovary, releasing the egg into the fallopian tube. LH, luteinizing hormone, is also what's responsible for converting the remaining follicle into the corpus luteum. So those two words should stick together in your mind. The corpus luteum is then responsible for the secretion of hormones as well. So this covers the section from the brain, from the brain's perspective. But remember that all of the cells here in the ovary are actually producing the estrogen and the progesterone. So you can see that during the first half of the cycle, these estrogens are rising, and that is because the hormones are coming from the growing follicle. So as the follicle gets larger and larger and larger, more estrogens are being secreted, or your level of estrogen rises. At the point that LH is secreted and ovulation occurs, then the corpus luteum takes over, and it produces a higher level of progesterone than it does estrogen. But you can see both progesterone and estrogen are being produced by this corpus luteum. Now, as the corpus luteum begins to disintegrate, because it just can't go that long on its own, it starts to disintegrate and the progesterone levels drop. As the progesterone levels drop, we're going to see some events happen in the actual uterine lining. So let's take a look at those really quick. Let me move this up here. Okay, so we've talked about brain hormones. We've talked about the estrogen and progesterone coming from the follicle and the corpus luteum. The estrogen and progesterone have a direct effect on the uterine lining, specifically the endometrium. So if we start about right here, as estrogen levels rise during this follicular phase of the cycle, you see that the endometrial lining starts to get thicker. So it's building, we're adding more blood vessels to this tissue, and this is helping get the body ready for implantation that would happen if a pregnancy occurs. Now, at the time that progesterone starts to be secreted during the second half of the cycle, called the luteal phase, because it's governed by the corpus luteum, we get even more drastic growth of the endometrial lining, and this is really getting the lining very thick and ready for implantation. That has to happen in order for the fertilized egg to remain healthy, alive, viable. It has to then implant into this thick endometrium. Now, if a pregnancy does not occur, then the corpus luteum disintegrates. And as it disintegrates, the progesterone levels drop. It is the drop in these progesterone levels that cause the sloughing off or the degradation of the endometrium. And once that happens, that triggers day 1 of the menstrual cycle. So once that endometrial lining starts to disintegrate, the tissue breaks apart, the blood vessels rupture, everything starts to fall away. That's when the bleeding begins of the period. So this is all a result of a drop in progesterone levels that happens at the very end of the cycle and triggers the beginning, number 1 or day 1, of the menstrual cycle. The menstruation typically lasts 3 to 5 days. In that time, estrogen levels are rising from the next follicle. That builds up the endometrial lining. That continues with progesterone until that progesterone drops and the endometrium starts to slough off again. If a pregnancy has occurred and the egg is fertilized, then these progesterone levels stay high. And what that does is that it makes sure that the endometrial lining stays thick. One of the particular ways that a miscarriage can happen is if a woman's body ends up experiencing a drop in progesterone levels, even if she is pregnant. And that ends up creating a situation where the endometrial lining sloughs off even though an implantation has happened, and that would lead to a spontaneous miscarriage. But there is a very distinct relationship we're seeing here between the hormones coming from the brain to the activity of what's going on within the ovary, the hormones produced by the ovary, and the thickness of the endometrium. And all of these have to work together to prepare the woman's uterus for an implantation with a fertilized egg.